Have you ever looked up at the night sky and seen a big bright light? That is the moon. For thousands of years, people have gazed at it with wonder. They have told stories about it. They have sung songs about it. The moon has always been a source of mystery and excitement. It hangs in the darkness like a giant lantern, sometimes full and round, and other times just a sliver of light. Ancient people used the moon to track time and seasons, helping them know when to plant crops or when to celebrate special holidays. It was like a giant glowing calendar in the sky, a friendly face watching over the Earth every single night. The moon is Earth's closest neighbor in space. It is a natural satellite, which is a fancy way of saying it is a space object that orbits or circles our planet. Think of it like a loyal friend that never strays too far away. While stars look like tiny twinkling dots, the moon appears much larger and brighter because it is so much closer to us. It is about 238,855 miles away. That might sound like a very long distance, but in the vastness of space, it is just a short hop. This closeness is why astronauts were able to travel there and walk on its surface. Even though the moon looks like it shines with its own light, it actually does not. The bright glow we see is really sunlight reflecting off the moon's surface, just like how a mirror reflects light. The moon is like a giant dusty ball made of rock. As it travels around the Earth, different parts of it are lit up by the sun. This is why the moon appears to change its shape throughout the month. We call these changing shapes the phases of the moon. Sometimes we see a full circle, a crescent, or even nothing at all when it is a new moon. The moon is not a perfect sphere, like a perfectly round marble. It is actually shaped a little bit like an egg, with one side slightly larger than the other. Its gravity is much weaker than Earth's, only about 1/6 as strong. This means if you could jump on the moon, you would fly up 6 times higher than you can on Earth. Imagine taking a giant leap and floating gently back down. This weak gravity is also why the moon has no atmosphere or air around it. There is not enough pull to hold on to a blanket of gas like the one that surrounds our own planet. How did the moon get there in the first place? It is a question that has puzzled scientists for a very long time. The most popular idea is called the giant impact hypothesis. This story begins billions of years ago when the Earth was still very young and hot. Back then, our solar system was a much more crowded and chaotic place. Scientists believe that a huge object, about the size of the planet Mars, came hurtling through space. They have even given this object a name, Theia. It was on a collision course with our young planet and there was nothing to stop it. Theia crashed into the early Earth with incredible force. Wow! The impact was so powerful that it sent a massive cloud of hot, melted rock and debris flying out into space. Imagine throwing a big rock into a muddy puddle and seeing the mud splash everywhere. This space crash was like that, but on a gigantic scale. The energy from the collision would have been greater than millions of volcanic eruptions happening all at once. The cloud of debris was made of pieces from both the young Earth and the planet-sized object, Theia, all mixed together in a fiery spinning ring. This ring of super-hot rock and dust didn't just float away. The gravity of the Earth began to pull it all together. Over time, maybe thousands of years, the pieces started clumping. Little bits stuck to bigger bits, which then attracted even more bits. It was like rolling a small snowball down a hill and watching it grow bigger and bigger. Slowly but surely, all of this material came together to form one large, round object. That object became our moon. It started as a glowing ball of molten rock, orbiting its much larger parent, the Earth. After this giant crash, both the Earth and the new moon were very different. The Earth was spinning much faster than it does today, and a day might have only lasted about 5 hours. The moon was also much closer to Earth than it is now. If you could have looked up into the sky back then, the moon would have appeared enormous, taking up a huge part of the view. Both worlds were fiery and covered in oceans of magma or melted rock. It would take millions of years for them to cool down and for their surfaces to become solid and hard. As the moon cooled down, its surface began to harden, forming a rocky crust. But its story was far from over. The early solar system was still full of leftover space rocks from when the planets were forming. These rocks, called asteroids and comets, were flying all over the place. Many of them crashed into the moon. Since the moon has no atmosphere to burn up these incoming rocks, they slammed right into its surface at high speeds. Each impact created a bowl-shaped hole called a crater. The moon's surface is covered in these craters, big and small. Some of the impacts were so enormous that they cracked the moon's crust. Hot lava from deep inside the moon then oozed up to the surface, filling these giant craters. This lava was dark and runny. It spread out across vast areas, creating large flat plains. When this dark lava cooled and hardened, it formed dark patches on the moon's surface. From Earth, these dark areas look like seas or oceans, which is why early astronomers called them Maria, the Latin word for seas. These are the dark spots you can see on the moon today, which sometimes look like a face or a rabbit. Over billions of years, the moon has been hit by countless space rocks. This constant bombardment has ground the surface rock into a fine, powdery dust called regolith. This lunar soil covers almost the entire moon like a thick gray blanket. When the Apollo astronauts walked on the moon, their footprints sank into this soft dust. Because there is no wind or rain on the moon to wash them away, those footprints are still there today, perfectly preserved. They are like a silent reminder that humans once visited this strange and dusty world far from home. At the same time, these rocks were hitting the moon, they were also hitting Earth. But something amazing happened on our planet. Many of the comets and asteroids that crashed into Earth were full of ice. As they hit our planet, they delivered huge amounts of water. This water eventually filled the low-lying areas, forming the vast oceans we have today. This water was the key ingredient that allowed life to begin on our planet. So, in a way, the same space rocks that left scars on the moon gave Earth the gift of water, making it the beautiful blue world we know. Even though the moon is far away, it has a powerful effect on our planet. This is because of gravity. Everything that has mass has gravity, a force that pulls things toward it. The Earth's gravity is what keeps you on the ground and what holds the moon in its orbit. But the moon has its own gravity, and it is strong enough to pull on the Earth. It does not pull the whole planet, but it does pull on the water in our oceans. This pull is what causes the tides. The water on the side of the Earth closest to the moon gets pulled toward it, creating a high tide. But wait, there is a secret. There is also a high tide on the opposite side of the Earth, the side facing away from the moon. How can that be? It is because the moon is also pulling on the solid Earth itself. It pulls the planet slightly away from the water on the far side. This leaves a bulge of water behind, creating a second high tide. As the Earth spins throughout the day, different parts of the planet pass through these two bulges of water. That is why most coastal places experience 2 high tides and 2 low tides every single day. The sun also has an effect on our tides, but because it is so much farther away, its pull is weaker than the moon's. When the sun, Earth, and moon are all lined up, their gravitational pulls work together. This happens during a full moon and a new moon. During these times, the high tides are extra high and the low tides are extra low. These are called spring tides. When the moon is at a right angle to the sun, their gravitational pulls work against each other. This results in weaker tides, with less difference between high and low tide. These are called neap tides. The moon's gravity does more than just move our oceans. It also helps to keep our planet stable. The Earth is tilted on its axis, which is why we have seasons. The moon's gravitational pull acts like a steadying hand, preventing the Earth from wobbling too much. This stability has kept Earth's climate relatively predictable for billions of years, which has been very important for the development of life. Without the moon, Earth's tilt could swing wildly over long periods, causing extreme and chaotic changes in our climate and weather patterns. Can you imagine what Earth would be like if the moon suddenly disappeared? It would be a very different world. First, our nights would be much, much darker. Without the moon's gentle, reflected light, only the faint glow of the stars and other planets would light up the night sky. It would be harder for nighttime animals to see and hunt. The rhythm of life for many creatures, from sea turtles to coral reefs that time their activities to the moonlight, would be completely disrupted. The night would feel emptier and a lot spookier without our familiar lunar companion. The biggest change would be to our oceans. Without the moon's gravity pulling on them, the tides would become much smaller. The sun would still cause some tides, but they would only be about 1/3 as strong as the ones we have now. This would dramatically change coastal ecosystems. The areas between high and low tide, called intertidal zones, are home to countless creatures like crabs, mussels, and starfish. Many of these habitats would vanish, and the lives of the animals that depend on the daily rhythm of the tides would be thrown into chaos. What if the moon moved closer to Earth instead? That would cause even bigger problems. If the moon were just a little bit closer, its gravitational pull would be much stronger. The tides would become gigantic. Huge waves would crash onto the land, flooding coastal cities all around the world. The constant pull and release of such powerful tides would also create enormous friction, slowing down the Earth's rotation much faster. Our days would get longer and longer. The immense gravitational stress could even trigger more earthquakes and volcanic eruptions as it tugged on Earth's crust. Over billions of years, the moon has actually been slowly moving away from the Earth at a rate of about 1.5 inches per year. That is about as fast as your fingernails grow. This means that in the distant past, the moon was much closer, the tides were much stronger, and the Earth spun much faster. The moon's slow departure is a natural process, and it will continue for billions of years. It is a slow cosmic dance between our planet and its satellite, a relationship that has shaped the history and future of our world. Even after sending astronauts to walk on its surface, our fascination with the moon has not faded. Scientists are still learning new things about it all the time. By studying the rocks brought back from the moon, we can learn more about the early history of our own planet. The moon is like a time capsule. Because it has no wind, water, or active volcanoes to erase its history, its surface has preserved a record of the solar system's past that has been wiped clean from Earth. Every crater tells a story of a long-ago impact, helping us understand the history of our cosmic neighborhood. Learning about the moon helps us understand the Earth in other ways too. For example, by studying the moon's core and composition, we can test our ideas about how planets form and change over time. Recent discoveries have even found evidence of water ice hidden in the permanent shadows of craters near the moon's poles. This is an incredibly exciting discovery. This water could potentially be used by future astronauts for drinking, for growing plants, or even for creating rocket fuel. It makes the idea of building a permanent base on the moon seem much more possible. And that is the big dream for many people, to one day live and work on the moon. A lunar base could serve as a stepping stone for missions to other more distant worlds like Mars. It is much easier to launch a rocket from the moon than from Earth because the moon's gravity is so much weaker. The moon could become a science outpost, a fueling station, and a training ground for the next generation of space explorers. The challenges are enormous, of course, but the dream of becoming a multi-planet species continues to inspire scientists and engineers around the world. So, the next time you look up at the moon, remember its incredible story. It is not just a bright light in the sky. It is a world born from a violent collision, a scarred and dusty companion that keeps our planet stable and pulls on our oceans. It is a keeper of ancient secrets and a beacon for our future adventures in space. The moon is a part of Earth's story and a part of our own. As we continue to gaze up in wonder, we are also looking toward a future where humanity's footprints might once again mark its silent, dusty surface, this time to stay.